Sorry, let me get more people in. Hello, everyone. So, first thing, if you don't have theta or x in your question and you have theta plus something or 2 theta, there is one important thing that you have to do first of all. Who can remind me? What is the first thing you're going to do, Fraser?
Change the range.
Exactly. So if you don't want to miss solutions, when you have an angle that is, instead of theta or x, theta plus something or minus something or 2 theta or 3 theta, the first thing you're going to do is to change your interval, because your interval is for theta, but we are going to solve for theta plus 30. So my new interval is going to be 30, theta plus 30, and 360 plus 30. Yeah, so I'm just adding 30 everywhere. And I would be careful when they don't include the equal here, because it could be that one of your answer is 360 or 0, but you don't want to include them in your answers. Yeah, so be careful, because some questions won't include the equal. Be mindful of that. Now, we are going to solve this equation for theta plus 30, find all the solutions, and then subtract 30 to have theta. Yeah, very quickly. I know all of you, when you see sine and cos, the first thing that you think, hopefully, is to divide everything by cos. Yeah, if one of them is squared, maybe you can use the identity, but if you have sine and cos and it's not divided by anything, what we are going to do is to divide everything by cos, so we have tan. So our equation, it will look like dividing by cos. I have 3 sine divided by cos is tan theta plus 30, and on the right I will have just 7 because cos cancel with cos. So we have the tan theta plus 30 is going to be equal to 7/3. Once we have that, we are able to use the calculator. So it's just going to do tan minus 1, and that will allow us to find theta plus 30. So theta plus 30, I hope everyone has the calculator there, is going to be tan minus 1 in degrees. So if you are in year 13, you are starting to work with radians, always check that your calculator is in the right unit. If not, you're going to give the wrong answer. Yeah? So calculator in degrees, and we get 66.001. I'm going to keep like 2 or 3 decimals. And before subtracting 30, we are going to find the other solutions in the interval. So this one is perfect, it's in our interval. The next one, remember, tan repeats every 180 degrees. So I'm going to add 180 degrees to that, which is 246, which still is in the interval. So the next one is 246.801. The next one, it will be out of the interval, yeah, because it's 426. And this is the limit of the interval. Now that I have my 2 solutions, is when I'm going to subtract the 30 to find theta, yeah, minus 30, and I will find theta. And these questions usually, look, they tell you what you have to round to, so don't lose 1 mark for don't look at them at that, yeah? So to 1 decimal place, this minus 30 is going to be 36.8 degrees, 216.8 degrees, yeah? 2 solutions in my interval, that's it. Why is important when we have these type of solutions that we find all the solutions first and then we subtract the 30? If in the questions that is theta plus or minus something, it really doesn't matter too much. But in the questions that you are solving for 2 theta, for example, or for 3 theta, you want to find all the answers for 2 theta or 3 theta and then divide by 2 at the end. Because if not, you are going to get all the answers wrong except the first one. If I find one answer for 2 theta, so this is like a different question. If I find the one answer for 2 theta, imagine this is 15 degrees. And then I divide by 2 to find theta, yeah? And then I have this one. And then I try to find the other solutions adding 180, for example. I'm not using BigMath, yeah? And I'm going to get the different answers. It's not the same. Divide by 2 and add 180, that add 180 and divide by 2, yeah? So be mindful of that. Find always all the solutions and then divide by 2 or add the 30 or whatever you have to do, yeah? If not, you will wonder why I'm not getting the answers. Does it make sense? Yeah? Then next one is completely independent of this one. And that's quite common in the trigonometric questions. So part A could be completely independent of part B, or they ask you to prove that you can write an equation one way and then solving it. So please don't skip the whole question, yeah, because it could be that you don't know part A and you can do the other parts. We have to show that this equation can be written this form. I would like you to try. So I give you 1 minute or 2 minutes to try to write this equation this way. It's not difficult. So you have sine multiplying a whole expression, and you have sine, sine, sine everywhere. So please try to, I'm going to make space, write that equation in that way. So I'm going to put everything in one side, and I'm going to factorize sine x and see if we get something useful. So if I put everything in one side and write sine x multiplying 3 sine squared x, yeah, from here, then this one negative, so minus 5, and this one positive, so plus 7 cos, we are very close to what we want, yeah? Look, the expression is all in cos, so this one with identity, you know that we can write it as 1 minus cos squared, yeah? So this one, remember, is 1 minus cos squared, and that's what I'm going to substitute. This is x, no? So we have sine x, and then 3 times 1 minus cos squared is 3 minus 3 cos squared x minus 5 plus 7 cos x. This is sine x. We have minus 3 cos squared. So minus 3 cos squared x plus 7 cos x, and 3 minus 5 is minus 2, equals to 0. If you factorize in the other side, so if you bring everything to the right, I brought everything to the left, if you bring everything to the right, you're going to have the same expression, but with positive 3, negative 7, and positive 2. And that's completely fine. Yeah? It doesn't matter, it's the same expression. Does it make sense? Everyone got the answer? Then, hence, we are going to solve for this. If you haven't done radians at school, it's okay. You can solve for minus 90 to 90, and it's completely fine. Yeah. So if you haven't done radians at the school, you can use degrees. If you have done radians at the school, you know that the only difference is just changing your calculator to radians. Yeah. But we are going to solve the equation exactly the same way. I'm going to solve this equation, but it says hence. And even if they don't say hence, it's very likely that it's helpful to use what we just done. I'm going to solve this equation, but instead of solving this one, I'm going to solve this one. Yeah, this here. How am I going to solve that equation? Who can help me? So I'm going to solve that. Hamza, tell me, how am I going to solve that?
Would you do sine x equals to 0?
Yeah.
I guess the brackets, you would just equal that to 0, but factorize. So you let cos x equal to y, and then just factorize it like a quadratic.
Absolutely. Absolutely. So I have two factors, they must be equal to 0. So I have sine 0, 0, and then I have the other factor equal to 0, and it's a quadratic. So I'm going to factorize it like a quadratic. Sine 0, 0 means x is 0. And then we will check the interval and everything. The next solution for sine, and think that we have negative. So if you want, we can work with radians or degrees. Because everyone has done degrees, let's going to keep 2 degrees if you want. So the next solution is 180. Yeah, 180 is above the interval, and the next one will be below the interval. So my only solution in the interval is going to be 0.
This is nighttime. Like, I love it.
Hilary, do you want something?
Sure.
It's okay. The next one, I'm going to factorize this. It's a quadratic. So I'm going to factorize that quadratic. Is going to be 3 minus 7 and 2. And I get 2 and 1/3. So if we factorize this quadratic here, we will have cos x equals 1/3 and cos x equals to 2. You know, this cannot be because cos is between -1 and 1. Yeah, you still would write it and then say it's not possible. Yeah, if you don't remember, when you do cos -1 in the calculator, it's going to give you an error, and that's why. Yeah, because cos is between -1 and 1. And then cos 1/3 is giving us 70 degrees. So x is going to be 70.52. They don't say to what, but I'm going to do the same than in the previous question. So to 1 decimal place, 70.5 degrees is in my interval. If you try to find the other solutions between -90 and 90, we are not going to have any other. Yeah. So these are my two solutions, x0, x 70.5. Yeah. Easy? Everyone? Any question? No? Abby, tell me.
If you put your answer in radians, would you also have to leave the answer with the unit radians, or?
Yeah. So if we, if you put your answer in radians, this one is going to be 0 because 0 degrees is 0 radians. If you put your calculator in radians, let me put my calculator in radians. When you do cos -1 of 1/3, you get 1.23. And that's what you would write. So instead of 70.5 degrees, you could write 1.23 radians or 1.2 if you run to 1 decimal place. Yeah?
Thank you.
Any more questions? No? All good? Okay, then more. This question, one of you asked me about this question, and I think is quite typical question. I don't have the answer, so you will have to trust me. But I think it's quite recent because I don't have it, so it could be even 2025 paper. We have, in this figure, we have a design for a feeding through, and the through is modeled as a hollow semicircular cylinder of radius r centimeters and length l centimeters. Is going to be made from a sheet metal and has no thickness. Yeah. Given that the capacity is 90,000 pi centimeters cubed, we have to show that the total area of metal required to make it is this thing here. Very typical differentiation question. They all start in a very similar way. So I hope you can see, you can picture the thing. Yeah, it's like a cylinder, but with two sides, yeah, to put food for the horses or the animals. So in these questions, we are usually going to have two variables, but because we are differentiating and you don't know how to differentiate with two variables, we are going to eliminate always one. So what are they asking us? They are asking us to write the area of metal, the surface area. So how would they write the area of this thing, the surface area? Amelia, what would you try to do if I write the area? This is going to be a rectangle and two semicircles. So what would be the area in terms of L and R?
You want to do the area of the rectangle, add the two semicircles. So is it L times R pi R?
Pi r, exactly. And so that's the rectangle. The rectangle is L, and then because the circle would be 2 pi r, but I only have half, it would be pi r. So I have L pi r. What about the two semicircles?
Would you just do, because it makes a circle, just do 2 pi r?
Exactly. Well, the area of the circle is pi r or pi r something.
Pi r squared.
Exactly. So that's my area, my surface area. But look, I have the two variables here. I have the r and l. Yeah, pi is a constant, it's a number. But I have two variables. And here, I don't have l. So I have to find a way of eliminating a. What can I use to eliminate a? L, sorry. Who can tell me? Any thoughts? Abby, what do you think I can use to eliminate, what information, if any, I can use to eliminate L in this expression? Do I have any numerical information that is going to help me?
the 90,000 pi centimeters cubed.
And that's why they give it to you. What is this?
The volume.
The volume. So what I'm going to do is to find the volume of this, making it equal to 90,000 pi, and from there eliminate the L. Yeah? Quite typical. It's always the same process. So let's go to find the volume. I think I'm going to do it on another page. I'm going to start squeezing everything. So the volume of that thing is a cylinder or is half a cylinder. Remember, the area of a cylinder is the area of the base. So pi r squared multiplied by L. It's like a prism. Yeah? But because I have half, it's going to be this. And we say that is equal to the 90,000 pi. Always, always, always look for numerical information, because they don't give it to you randomly. It's precisely to eliminate one of the variables. Yeah. So L, that's what we want to make. L, the subject. So L is 180,000 divided by r squared. No? Yeah, I cancel the pi, and then L is 2 times this divided by r squared. And now I'm going to go to the formula of the area that I wrote here. Yeah, this one. So L pi r, but instead of L, I'm going to write this. L pi r, and then plus pi r squared. Pi r squared. And now you're going to see that this is precisely the equation that we have to find, yeah, for the area, or the expression for the area. Pi divided by r plus r squared. Does it make sense? So this is this expression here. And now we have only one variable, which is going to help us to differentiate, because this question is about making the volume maximum or minimum, or the surface area. Yeah. If you are not able to find your way to this expression, still use it. So you will miss these 4 marks, but then still look for 2 to 1. Yeah, you still can get the rest of the question. It's going to be super easy. Use calculus to find the radius of the through for which A is a minimum. How am I going to find that radius? Daniel, what do you think I'm going to do to find the radius that gives me the minimum value? So I have an expression in terms of r. What can I do to find the minimum of that expression?
Would you substitute something in for it?
How do I find the minimum or a maximum of an expression? Imagine I have to find the maximum of this. How would you find the maximum of the minimum? Differentiate and make that equal to 0.
0, okay.
Okay, so that's what I'm going to do independently of the function. So every time I have to maximize or minimize something, I'm going to differentiate and make that equal to 0. So let's go into differentiate this expression. I'm going to bring this to the numerator as r minus 1, because we are more familiar differentiating that way. Yeah. So my expression, let me do here. So the area is 180,000 by r minus 1 plus pi r squared. When we differentiate that, dA by dr, and I'm differentiating with respect to r because this is my only parameter, I have minus 1 multiplied by the number pi and r to 1 less, and then I have 2 pi and r to 1 less. This is going to be equal to 0. And solving this equation is how I'm going to find my value of r. How can I solve that equation? Because it looks like difficult or strange. What is going to help me to solve that equation? Come on, those who have been with me for a while. What is helpful to do with that equation to solve it? What can I do with this? Fraser.
Would you like write that back as a fraction?
I'm going to write that back as a fraction, and then
you can get the r's to cancel. So then you only have one r, because you get negative 180,000 over r plus 2 pi.
to cancel. I don't have, sorry, I have a pi. I don't have an r here. So, but what can I do with
Oh,
this
yeah.
r squared? What I'm going to do with this r squared?
You can multiply through.
Exactly. I'm going to multiply, I'm going to eliminate the denominator, multiplying by it. So if I multiply everything by r squared, I have this plus 2 pi r cubed equal to 0. And now this is an equation that I know how to solve. Yeah. So every time you have, and this is quite common in this type of questions, r minus 1, r minus 2, it looks like an alien. You don't know well what to do. But if you bring it back to the denominator, immediately you are going to see, okay, I'm going to multiply by. Yeah. Could you cancel out pi? Yes, I can cancel out pi. Exactly. Yeah. 100%. Yeah. So that means that 2r cubed or r cubed is going to be, I'm going to divide everything by 2. So 90,000. And that means that r is cube root of 90,000. Yeah. Cube root of 90,000 is what? 44.81. And this is centimeters because our radius was in centimeters. Yeah, so this is the radius that is giving me a maximum or a minimum. I'm not sure. It could give me any, but this is my stationary point. Yeah, so I have differentiated the expression and make it equal to 0. Any question? No? Now it says, show that the radius found in part B gives the minimum value of A. How am I going to check that it's a minimum? Because I say it could be a maximum. How I'm going to check that it's a minimum? Can you all tell me in the chat? So please, what I'm going to do to prove that that's a minimum? Tell me in the chat. Because I know it's a stationary point, but it could be a maximum. Differentiate again, exactly, second derivative. And if it's a minimum, it's going to be how? Greater than 0. Yeah, I have it there. Exactly. So I'm going to differentiate again. And if it's a minimum, it's going to be greater than 0. Yeah, exactly. So let's go into differentiate again. I'm going to do second derivative with respect to r. And I'm going to go back to this one because the r is in the numerator. So I have minus 2 times this becomes positive, and I have 360,000 r to the minus 3 plus 2 pi. And this is going to be greater than 0 when r is any positive number, really. Yeah, when r is 44.81. Yeah, because this is positive and there is no reason for anything to be negative here. Yeah, this is positive, therefore it's a minimum. And this is B or C? Question, why would be minimal greater than 0 if it's minimum? Greater than 0, so the second derivative is, when the second derivative is positive, we have a minimum. When the second derivative is negative, we have a maximum. Yeah. Now, and one thing, it could be that these questions, and it's not unusual, these two parts are combined. So they ask you, find the radius for which the area is minimum and fully justify your answer. If they say that, when they mean by fully justify your answer means derive again and check that it's a minimum. So they are asking you to do this second part, but sometimes they don't tell you separate and specifically. But if they say fully justify your answer, that's what they mean. Check that it's a minimum because it could be a maximum. Yeah. Then, given that the sheet metal costs 30 meters per square meter, 30 pounds per square meter, calculate the minimum cost of sheet metal required to make one through. 30 pounds per square meter, we need to calculate the minimum cost that we need to make. What I'm going to do to find that cost? So I'm going to multiply 30 pounds for the square meters, but do I have the square meters? No, I have the radius that gives me the minimum area, but I don't have the area. So I have to find the area first. Yeah, so this is the radius that gives me the minimum area, but I don't have the minimum area. So I'm going to find the minimum area. So the minimum area is going to be the area formula that I have here with the value that I found. Yeah. Centimeters square in the previous question. No, because I have the radius only. When I find the area, it will be centimeters squared. This is only the radius. Yeah. So the area is going to be this value here. So the 180,000 divided by r plus pi r squared. And what I'm going to do is, no problem, 44.81 in that value. And that's going to be the minimum area. Yeah. So please do it with me. Well, I made a mistake with the calculator. If you get the value, please just type it in the chat or tell me. 1 plus pi. Okay, I get this value here, 18927.77 centimeters squared. That's the minimum area. Did you get the same value? Same value? No, same value? Yes, let me check them. No, we don't have the marker scheme. So please tell me if you get the same value. Yeah, and I haven't made a mistake with the calculator. If you get something different, you get it? Okay, thank you. And now they say 30 pounds per what? Per meter square? Per centimeter square? Per square meter. So be careful because we have centimeters squared. Yeah, so meters squared would be what? 1.89, no? So centimeters squares to meters squares, we divide by 102 times. So the meters squares, so this would be 1.89 meters squared. And what we are going to do is to multiply that by 30 pounds. So the cost will be 30 pounds times 1.89. Yeah, which is 56.7 pounds. 56.7 pounds. Yeah, that's the minimum cost. Calculate the minimum cost of metal sheet required to metal. So this is what they are asking us. And now state one assumption you have made in calculating your answer to part D. So what assumption that we've made to calculate this part? So we have found the minimum area and we are spending 30 pounds per square meter. Fraser, what would you say?
Is it that he can buy exactly how much and he doesn't have any wastage?
Exactly. So imagine you are trying to, these people will be selling sheets of metal that are wide and meters per meter. Yeah? So this could be as long as you want, but this will be a fixed wide. So the minute you're trying to cut a rectangle and then two semicircles, you're going to have waste and you're not considering that. Yeah. So that would be probably the same thing because we don't have the market scheme. I'm not very sure if they are considering more things, but that would be my first thought. Yeah. If you are trying to, you probably will need to buy more than you need to be able to fit the pieces and cut them. Does it make sense? Everyone? So this is the question. I think it's a very good question. It's quite common to have something that is a volume and so a volume and a surface area or an area and a perimeter. You have two variables, then you have to eliminate one, and then they are asking you a minimum or a maximum. Just remember this thing. If they only tell you find the minimum value or the value that gives you the minimum and fully justify your answer, you have to check derivating again that is maximum or minimum. Yeah. Okay, more. Unless you have questions. This is a mechanics question. So I hope most of you have seen Moments because it's one of the first mechanics 13 topics, but maybe you haven't. So it's going to be a bit tricky if you haven't. So a shelf consists of a horizontal uniform plank AB, is this one here. Length is 0.8, mass is 5 kilograms. So we have a couple of things here. Is uniform, is held by two inextensible vertical strings. So these ones attached at each end. A stack of bricks, each of mass 2.3 kilograms, is placed on the plank as shown in the diagram. So we have here a stack of bricks, each of them is 2.3 kilograms. Explain the meaning of each of the following modeling assumptions. For those who have seen moment, the stack of bricks is modeled as a particle. Can you tell me in the chat, what does this mean in this particular question? Yeah, because they are telling you in this particular question. So if I'm modeling the bricks as a particle, how does it affect this question? What would you tell me? Tell me in the chat as brief, or if you want to unmute yourself and tell me, what does that mean? In any case, yeah, so it's what happens when I model something as a particle? That all the weight, it has no dimensions, not accurate. I'm just putting all the weight in one point, in the midpoint. So if I have a brick, and the brick is on something, this weight, it will be all like spread. But we are not considering that when we consider the brick as a particle. We are considering that all the weight is in just one point, and our brick is just acting on one point of the plank. Yeah, that's what it means. The weight is focused on one point. Now, the plank is modeled as uniform. Who remembers this one? If you have seen moments. What does that mean? Come on, you're super quiet. Nana, tell me.
The center of mass is at the center of the plank.
Exactly. So when they say the plank or the rod or the bar is uniform, that means that we can consider that the center of mass is the center of the plank. Yeah, it's in the midpoint. So we are going to draw the weight in that midpoint. That's only that. So let me draw quickly because it's very helpful in these questions, the forces acting. So in A, I have a tension here. In B, I have a tension of the cable here. Then I will have the weight, we say because it's uniform, is going to be in the middle, and it's 5 kilograms multiplied by G. The weight is going to be the mass multiplied by G. And then I will have my bricks. And my bricks, we are not very sure. Let me write this in the other side. 5G. We don't know the weight, so I can write W, for example, or I can write, if you prefer, 2.3 kilograms and bricks and multiply by G. Either way, yeah, it's up to you, really. These are the forces acting. They say each of the strings will break if the tension exceeds 75 newtons. Find the greatest number of bricks that can be placed at the center of the plank without breaking the strings. So these bricks now are in the center. So I have something that is completely symmetrical. So if you get the idea is I have my plank, I have a force here that maximum can be 75 newtons, a force here that maximum can be 75 newtons, and I have my 5G and my bricks. How am I going to find the maximum number of bricks? I can take moments, but it's even easier if I consider forces, yeah, because this is in equilibrium. The forces pointing up are going to be equal to the forces pointing down, yeah. The resultant force is 0. So forces pointing up, I have 75 plus 75, are going to be equal to the forces pointing down, 5G plus W. And that way we can find W, or again, if we want, we can write 2.3 mg and then find N straight away. So let's go into do that. Resolving forces vertically, we have 75 plus 75 pointing up, going to be equal to 5G plus 2.3 mg. And we want to find N, yeah? So let's go to find N, calculator, and that's it. Everyone understand why we are doing this? So we are trying to find the maximum number of bricks for these tensions to be the maximum that they can be. Yeah, if they are a bit more, they will break. So we have 150 minus 5 times 9.8 divided by 9.8. and divide by 2.3. Yeah, I get n is 4.48. What I'm going to answer, can you tell me in the chat, what I'm going to reply to what is the maximum number of bricks? Four. And if it's 4.78, imagine I get 4.78, what I'm going to reply? 4 again or 5? Amazing. Exactly. If I have 5, so in modeling questions, always when you are rounding, don't round to the nearest number. Think, yeah? So even if this is 4.78 and numerically we would approximate by 5, if I put 5 bricks, the strings will break, yeah? So I have to round to 4, and not because it's closer to 4, but because it's the weight that it will support. Yeah, 5 will be too much, too many. So then this is B. Everyone is, yeah, it's clear? Now, find an expression for the moment about A of the weight of a stack of n bricks when the stack is at a distance x from A. State units for your answer. So we have, let's say that the bricks are here and this distance is x, yeah, from A. This is x. What is the moment of these bricks around A? For those who haven't seen moments is just, so remember in year 12 we work with particles, and when we apply a force to a particle, the particle is not rotating because it's just a point. When we have rigid bodies in year 13, which is bars, rods, planks, things like that, when you apply a force, apart from moving the thing, you can produce rotational effects, yeah? And the moment is just measuring that. Is the rotational effect of a force. It's going to be, the moment is going to be the force multiplied by the perpendicular distance, just that. Which means, in this case, the moment about A is going to be the force, and it says in terms of what? In terms of the number of, yeah, I'm going to write the 2.3 ng, so the force multiplied by x. It's as simple as that. So the force multiplied by the perpendicular distance. Okay? That's the moment of the bricks about A. So moment about A of that is going to be 2.3 ng multiplied by the distance. That's that. They say units because it's force multiplied by distance is going to be newtons meter, but not newtons per meter. Yeah, it's newtons multiplied by meter. Yeah, that's the moment. Very simple. Now, calculate the greatest distance from A that the largest stack of bricks can be placed without a string breaking. How do you think we are going to find that? So we now, it says the largest stack of bricks. So that means n is going to be 4. We are going to have 4 bricks, 2.3 kilograms each. How can we find the greatest distance from A? How do you think we can find that? Please think a tiny bit. Fraser, tell me, what do you think?
Could you do it on like rotation? Because if you disclose x as like an unknown distance, and then you say it would like rotate around A, one of them would cancel out, and then you could find out at the maximum point where that resultant force of the tension breaks. Does that work?
So if it says the maximum distance, yeah, so we want to bring it as far as possible from A. This is a moments question, so we will have to take moments. So where do you think we can take moments about?
Well, if you move it away from A and closer to B, it will start to tilt around B. So do you take moments about B? Because the resultant force of
So
TA would become 0.
Wait a second, because your reasoning is quite good. So if we bring it farther away from A, it's going to try to rotate about what did you say?
About B.
And which one is going to be the higher tension? So if it becomes closer and closer, if this in the middle, remember the tensions are the same, everything is symmetrical.
Mhm.
If I bring it closer to this one, which one is going to be higher?
The tension in B.
Exactly. So the closer I get to B, the higher the tension is in B. Yeah, I think that almost is not even mechanics, or it's just thinking a tiny bit. Yeah, if I bring my bricks closer to B, B is the string that is suffering. Because this is maximum 75, what can I do then?
Well, you can set that, you can set the tension equal to 75 because you know that the tension can't exceed that.
And
So when you take moments around A and set the maximum tension to 75.
Exactly. That's what I'm going to do. I'm going to take moments about A because I don't know what the tension here is going to be, but I know this one is going to be maximum to 75 because if not, I'm going to break the thing. And they're asking me the farthest distance for this thing to not break. Yeah. So what I'm going to do is take moments about A. For those who haven't seen moments, when things are in equilibrium, when I have a rod that is in equilibrium, two things are happening. The resultant force is 0. That's what we did here. So forces pointing up equal to forces pointing down, but moments about any point is 0, because if not, the thing will start moving, yeah, spinning. So moments about A, the moments about A must be 0, which means the clockwise moment, because the moments are going to try to spin the thing clockwise or anti-clockwise. So about A, this force is going to spin the bar clockwise. So this one is going to be clockwise. This one is going to be clockwise. Yeah, just following the arrow. And this one is going to be anti-clockwise. So the two moments that are moving the thing clockwise must be equal to the moment moving anti-clockwise. Yeah, the clockwise moment equal to the anti-clockwise moment, and that way they cancel each other. Let's going to calculate those moments. This one is 5g multiplied by the distance. The whole bar was 0.8, and this is the midpoint. So the distance is going to be 0.4. So 5g, 5g, which is the force, multiplied by the distance, which is 0.4. The other clockwise, I have 2.3, but I know I have 4 bricks. Yeah, so I can, I have 4 times 2.3, which is what? 5.2, no? 5.2g, 5.2g, so 4 bricks, 5.2g multiplied by x. That's the distance. And this is going to be equal to this one that we are going to use the maximum that it could be, so 75, multiplied by the whole length, which is 0.8. If you haven't seen moments, you will be, it's difficult to understand the question, but the moments questions are not difficult, I promise. Yeah, so when you see moments at the school, it will be fine. Does it make sense for those who have seen moments the equation? So the two clockwise are going to be equal to the anti-clockwise. I'm using 75 because it's the maximum tension that I can have. I'm using x, and I'm taking moments about A because that way I don't need to find tension at A. Yeah, because if the tension or the force past the point, the moment is 0 because the distance is 0. And from here we find x. So I'm going to give you the value because this one I have the mark scheme. So x is going to be 0.448. 0.448 meters. So you don't have to wait for me to do with the calculator. Yes? These moments questions, I think the ones that can be a bit complicated are precisely the ones that are telling you what is the maximum distance, or what is the minimum distance, or what is the range of the distance. Those questions are the ones that are a bit trickier because you really need to understand well the concept and what is happening. Yeah. Sometimes they ask you the range of x. So x, this brick could be between something and something, and then you have to find it and so on. Any question? No? Everyone is okay with this question? Sort of. Okay, then let me show you another one. This one is a modeling with quadratics, and it's from a year 13 paper. So quadratic sounds like, oh, this is very GCSE almost, but you have modeling with quadratic questions, and there are a few things that you need to remember. So let me show you, because this is going to be easier than the other one. The graph shows the path of a small ball. The ball travels in the vertical plane, and the ball is thrown from the point represented by A and caught at the point represented by B. We have the coordinates, and the height h in meters of the ball has been plotted against the horizontal distance. We have the graph here. The ball reaches its maximum height when x is 9. So we know when the maximum is, so x is 9. And a quadratic function h, linking h with x, is used to model the path of the ball. We have to find h in terms of x. Think the information that we are going to use to find that quadratic. And try to start. So what would I do to find the equation of that quadratic? I have 2 points and the x of the maximum. What can I do? I said.
Could you complete the square? Could you put it into completed the square?
If you have the y here, 100%. So if
Oh, we
they
don't have
say,
that.
yeah, if they say this is 12, then you will do a constant multiplied by x minus 9 squared plus 12, and that will be your quadratic, just substituting one of the points. And that will be amazing. It's not. They are not giving you the y. So if they don't give you the y, still you're going to use that information. But what are you going to do? What do I know about when the maximum happens? Oh, you're very quiet. Could you tell me in the chat? X equal to 0, x equal to 0. We have the y-intercept. That's going to help us. So when we don't have the maximum or the minimum to complete the square, we are going to write our quadratic, well, this is not y, it's h, in a very generic way. So we are going to write this. And then we are going to try to find the 3 constants. We have the y-intercept, which means this constant straight away is going to be 2. Yeah, so this is going to tell us that 0, 0, this is 2. Gradient equal to 0. Exactly. That's what I'm going to use for this value. So we know C is 2. So my H is going to be AX squared plus BX plus 2. So I need 2 equations. One is coming from substituting this point. So if this point is in the quadratic, substituting must satisfy the equation. So I have one equation that is 0.8 is 20 squared times A plus 20 times B plus 2. Yeah, that's one equation. The other equation is going to come, as someone just said, is that the gradient at x equals 9 is going to be 0. Yeah, so if I don't have the maximum, the complete maximum, the x and the y, but still I have the x, I know that the derivative there is going to be 0. Yeah, and that's where I'm going to get the other equation. So dh by dx is 2ax, just derivating the expression that I have, plus b, and I know this is going to be 0 when x is 9, because I have a maximum there. Yeah, that's my second equation, and I'm squeezing everything, and you don't know, I don't like that. So I have 18a plus b equals to 0. That's my second equation. So equation number 1, equation number 2, I will solve simultaneous equations, and I get a and b. Yeah? Here? Yes? No? So I'm going to write my equation in a generic way. With the y-intercept, I am able to find the c. Then I'm going to substitute this point, yeah, the y by 0.8, the x by 20. I have one equation. Yeah, I can simplify, write it better, whatever you want to do with it, but I have one equation. And now, because this is a maximum, I know that the derivative is going to be 0 when x is 9. Yeah, so I derivate, substitute the x by 9, and I make this equal to 0. And now I solve simultaneous equations. If you solve simultaneous equations, I'm going to give you the answer, so we don't stay here forever solving simultaneous equations. We get, so the quadratic is this one, yeah, minus 0.03. It must be negative because it's upside down, yeah? So minus 0.03 plus 0.54 plus 2. So that's our quadratic. Yeah, just solving simultaneous equations. You need to find A and B. Is this one here, everyone. Yeah? It's clear how we've done it? If we have the maximum, so if we know the y coordinate here, we will use complete the square form and we will have it in 30 seconds. Now, give one limitation of the model. I'm going to show you the mark scheme and you're going to see what they say. But in these questions, where you are modeling something, the trajectory of something, usually it's a ball or a stone or something like that that is flying in the air, you know that in real life it's probably not going to, it's going to be very close to a parabola, to a quadratic, but it's not going to be always perfect. And it's not going to be perfect for different reasons. So the ground is not going to be completely horizontal like here. So we are assuming this is flat, while in real life it wouldn't be flat, for example. Or you are ignoring resistance, you are ignoring rotational effects. Sometimes you, when you are playing with a ball, you know it's not going to be completely in a 2D plane. It's going to move maybe to the sides. So those are things that you are not considering in this model. Yeah, let me show you what they say. Where do we have it? H is unlikely to be a quadratic, the path is unlikely to be parabolic, wind may affect the path, wind may affect the distance, air resistance has not been considered, ball is unlikely to travel in a vertical plane, so ground is unlikely to be horizontal, that's what I was saying, there may be trees or other hazards, so you can say anything that makes a bit of sense and get the mark, yeah? Don't overthink. Then, next thing they say is Chandra is standing directly under the path of the ball at a point 16 meters horizontally from O. So we have a girl that is 16 meters, this is 20, right? So it's more to the left. So C is somewhere here, 16 meters, yeah, from O. And it says Chandra can catch the ball if the ball is less than 2.5 meters above the ground. Use the model to determine if Chandra can catch the ball. How are we going to decide if she's catching the ball or not? You can tell me. So she can catch the ball if the ball is less than 2.5 meters. Abby, what do you think I can do? I have the equation now, yeah? So
Would you take H using the equation to be 2.5?
and then what? Solve for X. So we have the equation, it's this one. And you say, let's going to substitute this by 2.5, no? And I get 2 values of X. And what do I do with that values of X?
Could you use that to find the Y?
The Y is the H. You're very close, but you're substituting the wrong thing. So this is the Y, this is the X. I know where Chandra is horizontally, 16 meters away. So what happens if I substitute the 16 here? What I'm going to get?
The H.
The H of what? The ball or Chandra?
Of Chandra?
What is this equation? The ball trajectory or Chandra's whatever?
The ball trajectory.
Exactly. So if I substitute 16 there, what I'm going to get?
The height of the ball.
The height of the ball. And what I'm going to compare that with?
The 2.5 meters.
Exactly. I'm going to see if C reaches if it's above 2.5 or below 2.5, exactly. So with the 16 meters, I'm going to find the height of the ball. And then if it's more than 2.5, she won't reach. And if it's less, she will catch it. Yeah, does it make sense for everyone? So these questions that are modeling questions sometimes are easy to do when you understand them, but they are difficult to understand. So let's going to do that quickly. We are going to substitute the x by 16, and then we are able to, I'm going to use the equation here. So h, when x is 16, is going to be 2.96. 2.96. So does he catch the ball? No, the ball is almost 3 meters high and she can reach up to 2.5. So what do you have to answer? Always answer what they're asking. Yeah. So what are they exactly asking? Use the model to determine if Chandra can catch the ball. So no, she cannot catch the ball. Yeah. So 2.96 is greater than 2.5 meters. So she can catch the ball. Yes. Clear? It's not that every single year you have a quadratic modeling with quadratic question, but it's quite common and they are not difficult, and they are going to give you, it's unusual, so they can give you to write the model or to find the model of a quadratic, they can give you 3 different things. They can give you 3 points, any point. So imagine instead of the 9, they give you a point here and they say this is 12, 7. Yeah, 3 points. Then you write your equation, general, and then you substitute the 3 points and you solve simultaneous equations with 3 numbers or 3 simultaneous equations. It's unusual. This is the least common. Yeah, they could give you the maximum completely. So when x is 9, y is 12, for example. Yeah, so this is 9, 12. And then what you have to do is to write a, and remember when we complete the square, the maximum is what makes the bracket 0, and the height or the y is when this is 0. So this would be your quadratic. So they're going to give you the maximum. So you complete the square and another point, and then you substitute the other point just to find the constant. But you need to write a constant, yeah, because there are infinite quadratics that has this maximum. So they would be steeper, wider, but there are infinite quadratics that have that maximum, which means you need a constant somehow. Yeah, this constant is, remember transformations, is just stretch in the vertical direction. So it's making your thing steeper or less steep. Yeah. And the other option is like this question, when they give you 2 points, and you will need both 2 points, and where the maximum happens, but not the y of the maximum. And then is when you have to differentiate always. Yeah, you differentiate and you make equal to 0 when x is that value. Is it clear? Do you have any question about any of the other questions? We had a couple of questions left, I think, but we will do them next week. Yeah. Any? No? Okay. Then I see some of you at 3:30, some of you next week, and some of you next time. Yeah. Enjoy the rest of the evening. Bye-bye.
Thank you.
Thank you.
Bye. Bye-bye.
Thank you.
Yeah.
Bye.